and we will go to lecture 5 and talk through some of the topics for edge computer vision. So one of the things that's pretty interesting about what's happening right now, it's actually a very exciting time to be doing this particular course, is that there's a proliferation of these objects, right? These, this one is a good example. This deep lens device. I'm sure and we're going to go over this today. We're going to get into how to use it, how to build it, build projects with it. But these kind of like holistic solutions that can have a camera, they have the hardware that can do the prediction, and then they go into a cloud environment, I think are the future of what's happening with machine learning. And then likewise, we're also going to get into this today, which is this edge-based Coral device here, which can do the predictions, computer vision predictions on the physical device, and are more powerful than your laptop at these specific tasks. And that's why people use these devices. So it's actually a very exciting time to be doing this course because of all the innovation that's happening. And what we're going to first cover is just the theory behind edge-based machine learning and talk through some of the things that are going on with edge-based machine learning. And in particular, I think one of the ones that's very interesting is this 5G environment. One of the things that's interesting about 5G is that you could potentially get rid of fiber networks. So I have fiber in my house, which is really nice because I can transfer data up and down. But 5G is fiber speed, and you don't need to have fiber connected to your house. And additionally, these devices could be put in locations where they're able to also have this fiber speed. And so it's opening up a new opportunity for we really don't know yet what people are going to do with this. The other thing that's interesting about the offline aspects of edge-based machine learning is that in many situations like a self-driving car or a drone or something where it's making life or death decisions, it's in the air. If it can't talk to the network, that's a big problem. If it can't make a prediction, so it's going to need to be able to make the prediction on the device so that you're able to really work without any network connection at all. So this is really a big one. And then, I think this might be one of the biggest trends for 2020 and beyond is the idea of privacy. And Apple in particular seems to be playing a role in the privacy. And in the United States, this is becoming an issue where, at first, I think maybe 2010 to 2020, people were okay with giving everybody their data. But now they're much more concerned about what's happening with their data. And in particular, Apple is probably one of the best players in this space in that they have hardware they're developing where all of the predictions themselves happen on the hardware. And so this would be an edge-based device. So your phone and the iOS devices like the new watch, all this, they all can make predictions on the device, and they don't have to send it to somebody else. And this is probably going to open up a lot of opportunities for development. And can you develop applications that maybe are trained somewhere else? They have all the information and the data inside to make the prediction, and then you put it onto the device, and then the device doesn't have to send it back to people. So even if you don't believe in privacy, that it could be lucrative in terms of that is what customers in many nations are looking for, is can you do predictions where it is actually secure, so you don't have to send your data outside the network. And then we'll also talk about this a bit, is this concept of application-specific integrated circuits. So what are these unique chips that are building solutions? So we have another one, the Intel Movidius chip that Intel is coming out with that can do predictions. A lot of these solutions are as a result of the fact that CPUs are not getting faster anymore. So, and actually, a really good example of this would be the Apple Pro a computer, which is ridiculously expensive computer, like it can be like $50,000, for example. This computer is a good example of something where it's like, whoa, what is this? Why is it so expensive? But if we look at some of the things in here, one of the things that's interesting about this, if we just pick one of these, is that notice that even though it has 28 core processor, that which would be fun to have, that's only part of the story. The other part of the story is that they also give you the ability to choose a graphics card, and the graphics card can be used for video transcoding, for GPU programming, things like that. And these are very expensive. But even further, they also have something called Afterburner card. And the Afterburner card is a specific card that can do decoding of video. And so it's a specialized chip. So basically this computer itself, it has a $2,000 card just for video editing, if you were like in film or something like that, that has another $5,000 you can get in graphics cards. And that's not even the core chip, right? Which is this 28 core machine. So really this shows how what's happening, if we go back here, is that these specific cards are doing work because we can't really put any more processors. The CPU is tapped out. It's not getting faster. There's only so many processors you can put into a machine. So these companies have to develop other technology that is special purpose to something like video editing, deep learning, edge computing. So in terms of the industry here, every player, really every major tech company has some kind of inference solution, a prediction hardware solution. So AWS has a bunch of chips here. Google has a bunch of chips here, and we're going to get into those. Also, Apple has a bunch of stuff. We just talked about it, and then Intel. So let's talk about just a couple here. These aren't all of them, but in particular, the Intel Movidius. Here's an example of it. What's nice about this style of chip is that it's USB based, so you can just take it, plug it into your machine, and then now you have a very powerful prediction chip that is just available via USB. So I think this is really the style that you're going to see a lot of computer vendors do. And this is just emerging. We're going to see an explosion of these kinds of chips. And in particular, what is it? Well, it's a tiny fanless deep learning device for doing AI programming at the edge. And you can see here that you download a model, you go to that model, you go through and do some development with it, figure out what it is you want to predict. And then finally, when you're done, you put it wherever you want to put it. And it could be on a Raspberry Pi, it could be on a physical laptop, it could be on some other, a drone, it could be wherever. And the way I've typically done this, if you do want to use the Intel Movidius chip, would be to use a Ubuntu virtual machine. And why I like the Ubuntu virtual machine is that it isolates your development environment to this physical virtual machine, where even if you're on, like I have an Ubuntu laptop, but I still would put it into a Ubuntu virtual machine so that I have total control over the development environment. And I could have different virtual machines that are isolated to different hardware. And that way I can isolate exactly what's happening, make a copy of it once I've got it set up. And I think that is an important thing to think about when you're doing hardware development, which this is. It's good to have a clean environment that you can recreate. And I think a virtual machine is a great way to do it. So once you get a virtual machine set up, you would go through and download the SDK. And then from here, we can just look at some of the different information about this particular kit. So let's see here. I don't know why that's blowing up on me, but maybe that one's down. Let's look at this one. So this compute stick here, one of the things that's interesting about it is that you can look through their examples, and their examples are available here in apps. And you can see that there's multi-stick examples. There's also individual examples as well, like these little Python scripts here. And there's not necessarily even a ton of code to get started, but this is a good kind of like a hello world to get started with it. Is run a few lines of code, make sure that you can get it to work. So that's what I typically do is I'll download the code. And here's one more example repo. That's probably a better repo. I'll go through here, find one of these example projects here. I think this one has a little more stuff in there. And then I'll get the hello world working first. And the way you do this is you say make run. And then if it's not plugged in, it'll tell you that the device isn't connected. And this is a lot of times easy to get caught up on, is when you get physical hardware, is you don't do just a hello world, like does anything work? And you could get way down into writing code, and then you think that it's your code, which your code could be perfect, but it's not your code. It's actually the fact that you don't have the device connected properly for some reason, like the driver is not detected or the library or whatever. So I think this is a very, very good idea to first make sure that you can connect to it, right? So you have a hello world. Once you do that, then I would move on to the next step, which again, if we go back to here, there's a bunch of examples of projects that you can get started with. And this is a good way to get a feel for what you can do with this device. And I think this one's a benchmark here, which is pretty neat. So this one shows how to determine the frames per second or inference per second you're achieving with your current configuration, which is pretty cool. So you can go through here and see, like, if you are going to do a real-time computer vision application, here's how to actually run this project and benchmark it, which could be very helpful if you were going to build let's say a license plate detector, or like a trash sorting program or something like that. Then a few other ones that I've seen that are pretty neat are, for example, the driving. Let's see, real time. I think there was a real time object here somewhere. Let's see, was it this one, driving? Autonomous Lego driving. That's pretty cool. But there was one that it was, maybe it was the object detection. Maybe that's the one it was. No, I guess this, I don't know where it is in here, but basically there's a bunch of examples here. And gender age is another one that's pretty neat, where you can, on one chip, it can simultaneously do two different types of predictions because of how powerful it is. And so this can detect the age and the gender at the same time. And it comes with a pre-trained model. And this model is from something called Model Zoo right here. And so you can see this is the Model Zoo. And here's one I ran a while back using the Model Zoo. Is I just took this onto my Ubuntu virtual machine, put the pre-trained model, said make run, and then it captured my camera, and then I get a pre-trained model, and I can get access to it. And what's neat about this is that you can actually, it's just Python code, so you can wrap that Python code, and you could, as it's collecting, let's say the labels, you could put the labels somewhere else. You could put them into a text file. You could send them to an API somewhere. You can do whatever you want. You could build a GUI on top of it. You could send it to another device. It's up to you as a programmer to decide, what it is that you want to do. Now, a couple of things I'm going to mention about this just briefly is that additional to this, there's another tool called ONNX, which stands for the Open Standard for Machine Learning Interoperability. And so this is another really interesting thing to be aware of, is that you can actually use this open format to convert models from one version to another. And I was just looking at this earlier today. And if we say Azure ONNX Core ML, this would be a good example. I think it's this one is the one I was looking at earlier. Is that, let's see here, deploy it. There was, get this. how to use, this is the one. Okay. So what this does, for example, is it shows you a bunch of different examples of how to use Onyx. And I think the one that I was looking at was this one. AML Tiny. Let's see here. This was... Let me look at this. If this is the one I was looking at earlier. Yeah, this is the one. So let me actually even put this into a maybe I'll just put this into this notebook and save it. I'll just put a section here that says Onyx, and this is really a pretty interesting new tool here. And we'll go here and just say example. Just do this, say example of CoreML conversion. I think that's how I do it. Right? Does that work? Oh, I'm missing there we go. And so I think that this should work. Or is it, why am I screwing this up? Or is it the other way around? It's this. One of these will work, where you give it the link. There you go. And then I'll just check this in. Save a copy in GitHub. So why is this so cool, and why am I showing this? Well, the main thing that's interesting about this is that you can take a model that anybody gave you, and you can convert it into some other format. And in particular, this one is a great example of that. So they say, this kind of walks you through. It says, okay, what is YOLO? It's a real-time object detection using Onyx on Azure ML. You don't have to use Azure ML, but you can. And then what is it? It's an open format for representing machine learning models. And what's great about it is it works with a community of partners like Microsoft, Amazon, and you could explore more there. And then YOLO is you only look once, real-time object detection. So we've already got a model somewhere. And if I want to go through here and run this, what I can do is I can say, check the SDK version. And then the first thing I do is I download a model someone else created earlier using a different framework. And in this case, this framework is called CoreML, which we'll get into in a second. And then once I download that model, what I can do is I can use Onyx tools and also import CoreML tools, load it into this example, convert it into the Onyx format, put some additional information in here that the model needs, save it out, and then it's ready to go. And now it's in Onyx format. So what could you do with this? Well, because it's a cross platform model format, you can put it anywhere that accepts Onyx. And so one of the places, if I wanted to, so let's say that I originally this was running on an iOS device, right? I could take that same model, or even if I used, and we'll get into this, if I used Apple's training system to develop something, I could train it using their AutoML system and then dump it to this format and convert it. You also could then deploy it as a web service as well. So I go through here, I set up some cloud stuff, in this case, loaded Azure ML Workspace, register the model, and then now I go through and I can do a prediction. So here's an inference that you do against it. So in fact, I can even show you the first part of this in action. So let's go to Azure real quick, and I'm going to go to their system here, and I'm going to go to their system called, what is it called again? It's called Machine Learning Studio. And in Machine Learning Studio, I will go to launch the studio and then go to a compute node and just run this in their cloud. So I'll click on Jupyter, and I think I even have this code. Here we go. Yeah, Onyx conversion. I was just working on this today. And in particular, what's awesome about this is that it's pretty straightforward. run this first shell, and the first shell just downloads this model, which is the CoreML model. The second thing that I would do is optionally install these tools. These are already pre-installed in Azure, but if you needed to do this on your local laptop, you'd have to install these. And then from here, I run this next part, which takes the model I downloaded and puts it into this utility CoreML tools. So we'll run that. Let's see if this works. Great, looks like that worked. And then what I'm going to do is I'm going to convert it from the CoreML format to the Onyx format. And it's literally a line of code. And I just say Onyx tools convert, and then I go here and I do this. Great. And then I save it out. So I just say save it out, and then I can double check that it's literally on my machine here, right? And I can do this. If I want to be less geeky, I can just do this. I can say ls-lh, and then just do this, which will show me it in human readable form and verify that I was able to save that out. There we go, 61 megabytes. So a little bit beefy. I mean, it's a little bit of a big model here, but this is really powerful, because what this means is that you can take models from anywhere and kind of go back and forth and put them wherever you want. So I do think this is the future of what's going to be happening in machine learning and edge-based computer vision. So that's Onyx in a nutshell. Now, if I go back to the other thing I want to talk about was CoreML, which what's interesting about CoreML again is that Apple, because they own the whole ecosystem, there's a very good story for doing machine learning on their device, and they accept a ML model using CoreML. They have a framework called CoreML that can interpret that model, and it is easy to integrate it into your app. So this workflow could be very good for doing things from, let's say, Google AutoML. We also know that other computer vision AutoML systems would work very well with this as well. But if you do the Google flow and you train your model, one of the ways you can export it is through ML model, and then that would get put onto your machine. So what are some of the key concepts? That it's optimized for on-device performance. So it's really designed to run on the iOS device. There's also low memory as well. And you can convert these just like we could with Onyx, where we took a CoreML model and put it to the Onyx format. You also can take some other model and you can convert it to CoreML. And so how would you do that? Well, one of the ways you would do this is you would say pip install CoreML tools, which I think we did over here, which was, CoreML tools right here. So you can go the other direction as well. Then you can say convert model like this, save the model to CoreML format, and then now you've converted it from, let's say, Caffe. Like we know that the zoo, right? This zoo has all these models here that it makes that are in the Caffe format. Well, I could take that model from the Caffe format and then convert it into ML model, which again, I guess I could take from ML model and I could convert it into Onyx. And so here's a bunch of examples of how to do that. Like if I just wanted to play around with this in here, pip install CoreML tools, go through here and import CoreML tools, and then I could basically play around with the object. So I could do this, like make an instance of it, and if you did a question mark, it will show you the help menu, and I think the help menu will show us that this will accept a bunch of different. This is the documentation on it. It'll show you all the different formats and how, and even examples of different libraries and all kinds of stuff just by doing this help menu thing here, which is this question mark, right? So you can get the help on it. Or you could also do this. You could do dot and then tab. So convert dot, and you could, it'll show you the different formats that you can convert with. So anyway, that's how I would convert. Now, how do I use this inside of a machine learning application? Well, the this demo project here is one of the best ways to get started, which is the classifying images with Vision and CoreML. So you don't have to do anything. It already comes with the a model that can do 1,000 classification categories, and over here you would just download this, set up a Core Vision model, and then load it up into your project and run it. Now that's if you wanted to pre-train a model. The second option here would be, which I think is also very interesting. This is a fairly new one, and I'll just put this as a link in here as well. So let's just maybe say option 2 here. We'll just do we'll say create ML. And this would be like, you can also build AutoML solutions that work the same way. So you don't have to necessarily do things by downloading the model. You also could just train it yourself by going through, organizing some images, putting them into a classifier, training the classifier, and then building it into an application. And so really, again, the core idea with AutoML, and we've got, Google's got it, Amazon's got it, Google's got one, Amazon has these, and Azure has this, and Apple has this, that you can train these things by really just clicking buttons. And then once it's trained, you would create an ML model format like we just discussed, and then you can build an iOS app around it. So what is interesting is that you could actually build this here and then put it into the cloud if you wanted to. So the device isn't necessarily the only place that this model could actually live. So that's really the gist of this. And if you look inside of this particular project, you'll see that the CoreML model lives inside of here. And so you'd say mobilenet.ml model, and then compile it, and then you'll get a prediction like this. And again, so you have a couple different options here. You could just download the model from this location, or train it yourself if you want to stick in the Apple ecosystem. Now, there's another thing that I'll mention here as well, which I'll just minimize this real quick. So let's minimize this. Is that there's also the TF Hub, which we'll get into in a second. TF Hub. And inside of here, what's cool about it, if we go to TF Hub, is that the TF Hub is a way of looking through models that have been created by other people. And again, if I wanted to go through here and do image detection or image classification or whatever, I could just download this and put this onto a device, because it would come in this TF Lite format. And what's neat about this is with TF Lite is that I could potentially build a bunch of different, we could say, convert to CoreML. I'll put a link to it here. Maybe also you could do, comes in this format, and you could also do, again, convert to, and put a link here. So here's this. So you can convert to the CoreML format. I don't know why I'm having problems with this. There you go. It converts in the CoreML format. It also could do the other way. You could convert to Onyx. You could also deploy directly to the Coral hardware as well. Coral hardware. Right. So this is kind of an interesting toolkit that when you're building solutions, you don't necessarily as well even need to train your own model. You could use something like TF Hub, download it, put it onto a device, then run it, and that might be good enough. That might be good enough for you. So you almost treat it like it's an open source library, but in this case, it would be open source machine learning model that you would use. So let's talk a little bit about that workflow a bit next here, is to kind of get into this Google ecosystem. So if I go to the GCP console here, the workflow that I've seen most students do is that this is probably the golden path, or the easiest way to do things, is that you would go to AutoML Vision and you would upload some stuff. So here we go, AutoML Vision. Here, you would create a data set inside of your, again, this is a flower data set. Train your model. And when you train your model, what's very important is to pick the mobile-based model. So if we went through here, we said train, we would select this option, Edge, right? Download your model for offline use. And if you say continue, really doesn't matter that much when you're selecting your goals, other than that you would want to decide how important is the highest accuracy versus the fastest prediction. So the smaller it is, it can make very low latency predictions. And maybe that is actually important for, let's say, driving. Like if you're going to do something with real-time object detection for vehicles, maybe you would want to have very low latency, where if you're detecting, let's say, handwriting, maybe like this would be better to select. But let's just say we pick one of these. And then once you train it, again, you can use a bunch of hours for free when you start. But what will happen is, if we go to test and use, is that this model will allow you to download it in one of these formats. And so I think for a student that is going to do, probably the easiest workflow is either going to be this one, TF Lite, the CoreML, or the Coral. Those are probably the three workflows that are the easiest. Now, let's just look briefly at this TF Lite workflow again here. Is that really the core idea is that you train your model in the cloud, and then you go through here and download the trained model using this project. And then it is simple as swapping out the model that they give you with the model that you trained in the cloud. So that's really the gist of this particular project, and it'll appear as a labels.txt file and a graph.lite file, right? So this would be, and I'll just throw this in here, would be, put another section as devices, for example. So, additional devices. We could go to, we have the Android from TF Lite, right? That's one. And then we also have, if we go back to this, we could also pick the CoreML. So we know a little bit more about the CoreML now. So we could export that ML model and run it on iOS or Mac OS. So if we click here and we go to the view documents, it's the same thing we were just looking at earlier, which is that Apple device will accept the model that was exported from Google. So Google will export it directly into the CoreML format for us, which is great. And so we can say here, iOS here from we'll say Google AutoML, right? And then the next one would be, if we go to this, would be the container. I think is less relevant for us, but I would say Coral would probably be the next one that I would talk about. And I'm going to demo this in a second, is how to do this step by step. But basically, if we go to the products here, the one that I think is probably the easiest to demo is this USB accelerator. And the reason why it's easy is you just plug it into your computer, and it works well with Debian Linux, OS 10, Windows, compatible with Raspberry Pi boards. Pretty straightforward process to actually use this particular chip. And what's great about it is it has a TPU physically on the piece of hardware, right? So it has the prediction engine on top of it, and you can see here these are the instructions, the quick start on how to implement it on your device. So how to set up the USB accelerator, how to perform an entrance, and then later how to create your own model. So I'll just say this would be another option here, which would be that download from Google AutoML and put onto Coral AI. Here's another one. And then yet another, we'll call this additional computer vision devices and workflows. There we go. So I'll also just save this real quick. So what's neat about the Coral one is that it is in a way one of the most straightforward workflows, that right, because again you can just export this and it'll give you the TF-Lite file, and you can download it. So what I'm going to do is I'm going to shift gears here and just show you that workflow from the Coral products flow. So what I can do is just go to the documentation here and just set up the accelerator. So again, you can see super small device here. It's going to require, if you're using OS 10, you would need to use either Mac ports or Homebrew. I think Homebrew is a little bit better, and you need to install the runtime. So what I can do, I think I can just put this in one window and then share my screen so that we can have the web stuff on one side and then like a terminal on the other. So I'm gonna change that real quick. Is I will go like this and just change it so that it's a little bit smaller here, like that. And then I'll open up, I'll stop and reshare again and put a terminal right next to it so that we can see both at the same time here, which I think will be a good way to do this. So I'm going to stop my share and reshare. Follow the OS 10 instructions. So I would do this first. I would run this. I would go to a different directory, for example, like my source directory, and then I would run this curl command, and this would just download the package that has the runtime in it. And then I would unzip it. So Edge TPU runtime 202.zip. Let's see, there you go. Unzip that, and we'll say replace it. Okay. Okay, so I got this thing replaced, and then the next thing that I'll do is that I will cd into that directory. TPU runtime, and then I will run this bash install. So I'll say sudo bash install.sh. There we go. So it goes through, asks me for sudo password, and it says a few things. It says when you first install this, it's going to tell you, do you want it to get really hot? Because if it runs at full capacity, then it'll be a little bit hotter. And so sure, why not? We're playing around. Let's do maximum frequency, and so I'll go ahead and do that. And this is typically not too bad. And it goes through and installs the libraries that I need. And so while that's working, I'll go to the next step here, which is it's going to say now connect the USB to your computer using the provided cable. So in this case, I've already done that, so I can just leave it installed there. And then I'm going to go to this next step, which is install the TensorFlow Lite library. and this is a little bit tricky because anytime you install Python, you can get yourself into trouble on a machine like your laptop. And so what I would recommend is anytime you're installing libraries is you create a virtual environment first. And so let me just actually also make this a little bit more like this. Okay, so next up, what I will do is I will create a virtual environment. And for here, it's fine. I'll just put it in somewhere around here. So I'll say Python 3 tilde slash dot, or I say dash m for virtual environments, and then call this TPU September or something like that. There we go. And that creates this virtual environment. And then maybe make this a little bit bigger. That looks pretty good. And then the next thing that I will do here is that I will, let's see here. I will go through and say pip install to pip install the right thing. Oh no, first I'll source it and then do a pip install. So I'll say source tilde slash dot TPU bin activate. There we go. And then I will, inside of this directory, I'll do these two things. So I'll make a directory called Coral and cd into it. Let's go ahead and do that. And then I will get this tflite directory, which will contain the models and also will contain some examples as well, right? So this basically will give me the model file, the tflite model file, plus it'll give me some classification examples. But this could be very similar to what would be downloaded from Google AutoML. So go through here and I clone it. Okay, great. And now I would just cd into this directory, which would be the Python examples here. So let's say cd, whoops, here. Once I've cd'd into here, I can run their install script. And that looks pretty good. Okay, and what's great about this next is that I can run the image classifier with the bird photo. And so what will happen is that it will run this command line tool called classify image. And maybe we can just look at this real quick. In fact, is if we say vim classify image, we can take a look at what the script is. That's always a good idea before you run some code, is just see what it's doing. So it's got some documentation that says how to use it. And what it does is that it has some labels inside of here that it loads. It finds the interpreter, which would be the tflite interpreter, which will allow it to talk to the physical hardware itself, and really that's it. And then this part of the code is just a argument parser that accepts different things. And then from here we would get the prediction result, and you can see that it puts some print statements in here. So you could change this and make it do whatever you want, right? This is just like an example piece of code that they have, and so we'll quit that. And then I'll run this example. So let's go ahead and just copy this. And what this should do is it should pop open a parrot and predict it if we have the tflite runtime. Now, what I don't know is, did we not install the runtime? I think I didn't install it. Okay, so I need to go to here where we skipped a step. Okay, so I'm going to go to the runtime, and I'm going to say that I didn't click on this link, which is install the runtime for Python. So I need to select the right environment. And in this case, it's going to be OS 10. And actually, here we go. It says run an inference using tflite runtime. So I'm going to need to select this particular binary. And what I would do is I would say pip install. And then because it's in a virtual environment, it'll put it in this virtual environment. And then we would just need to download this binary right here and install it. So we'll go here. That looks good. And we've installed it. That looks successful. So in theory, that's all I needed to do to go back to this other step, which I think was right. It's one of these, which, well, I'll scroll down here. I think it's, yeah, right here. So this is the step. Let's go ahead and run this again now. And this in theory should work. Let's see. There we go. So it was able to detect that was a parrot and give me and told me exactly what kind of parrot it was. It was a scarlet macaw parrot, and it said it was 77% sure. So let's look into this a little bit more though and see what it's doing. So one thing it's doing is in the models directory, notice it says there's a labels. So we should be able to see all the things that it's got inside of here. So if I go into the models directory here, we can look into a little bit more detail. That you notice that it has a, I think the model we're using is Edge TPU, and then it also has this INAT bird labels. So if we do this, we can see that these are all the different birds that it knows how to detect, right? That's a lot of birds. I don't even know what most of these birds are. But what we could do is actually look into this a little bit more and maybe find one of these birds on the internet and test it out a little bit more to just get a better feel for how this system works. So I don't know, how about cliff swallow? Let's try that. And so I'm gonna go here and I'm gonna see if I can find a picture, American cliff swallow, and Wikipedia has a picture here. I guess in theory I could even programmatically call to Wikipedia and grab this, but let's go ahead and download this image, and I will say save image as, and I'll put this onto my desktop. And then what I can do is I can potentially go up here, and I think there's it says images. I can maybe move it into that images directory. So I'll just say mv tilde desktop, and then something, this thing. Sure, I'll move this into images here, and then, but let's call it something a little less big. So I'll just call it the first part of it, and then .jpg, like that. And did that work? Okay, that looked like it worked. And so now I can try to predict a different bird. And so let's see here. All I would need to do is just go to this last section here, which would be this, and then pass in the name of this thing, which would be a PE. There we go. And let's see if that works. And it goes through, it tries this prediction, and it was able to detect or predict that it was 82% probability that it's a cliff swallow. So pretty powerful, actually. That, and again, my laptop couldn't do this. This is a very powerful chip that's doing all this work. Now, what also is cool about this is that in theory, we could just grab the model from from Google AutoML, right, and train a model, download it, put it on here, and do the exact same thing. Or we also could download one from the TF Lite hub as well. And so to do that, we could actually go to this and see if we can find one from TF Lite here. that we could use. So let's see what this is. This is a collection of MLKit compatible TF Lite models. So this one, let's see, what does it contain? There's a bunch of models here. I think we can just download one of these and see what we can find. So maybe let's see if we can find one that's maybe plants. That looks like a good one. So if I click on this and I want to download it, I should be able to just an updated version here. Okay, maybe make this a little bit bigger so I know what's going on here. So I should be able to go to this project and download it. Where do I download this thing? TF. Download. Mobile Plants Classification Model. Okay, let's download this. All right, we'll put this onto my desktop and let's uncompress this thing. And then again, in theory, that I could, let's just look inside of here. Let's see what happens if I just move that from my desktop. And I think it was called, let me just grab this thing. Here we go. It's got, I can just put this in this window, move this to here. And then if I look inside of this, we can just see what's inside of there. So what is in here? We've got a TF Hub module. We've got some assets, some variables. So this one might be in a slightly different format that I'm. Oh, you know what it is? I downloaded the wrong version because I think that's the protobuf format, and so I would need to download the TF Lite format. So maybe I need to get less complicated here, and I need to do a filter for TF Lite, or even I think you even should say Coral. Here we go. This is the one that we're using, and let's just take, just to make it simple, I'm going to go to Coral, and I'm just going to try to get any of these to work. If I can't get this figured out in a second, then I'll just move to the next section. But I think this looks good. Let's see. So Coral Edge TPU, this looks good. Let's download it. Again, I will uncompress it. Okay, so this looks like it's just got a, oh, and then here's a labels file. Let's download that. Okay, this looks good. Let's ImageNet labels. Let's just do this. So let's just copy this. We'll call this image. So yeah, I think I can do this now. I think I know what's going on. So I'm gonna just remove that other model here, and then I'm going to create a new, inside of the models directory, I'm going to create a new labels file. So I'll say touch, and I'll do the same name that they have, which is called this, which is ImageNet labels.txt. Okay, then I'll open that up and put these labels inside. So this will give me the ability to do predictions based on this model that I download here. Okay, so let's do this. We'll say set paste, and I will copy this, and there we go. That looks pretty good. So it looks like it's able to detect a bunch of different things, like just kind of a bunch of images. Okay, 1,000 images. I will save this. That looks good. And then the only other thing I will need is that model, wherever it put it, which I think I already downloaded, which in theory is on my desktop somewhere, called TF Lite. Oh, I think I see it. Yeah, so I'm just going to CP this model into here like that. and I'm going to just copy it to the directory. So I got label, got model, and so again, in theory, I should be able to do that same command line tool that I ran earlier. So I can even look at history and do like this command here, like this. So I could even do exclamation point. This is one way in history you can actually run an older command. In fact, let me just do this. I'll put this higher up. I'll go like this. So this is the way in history you can run any command that you ever run again. You can just call back, which is pretty helpful if it's a big command like this. And I'm just going to swap out the label for the other label, right? So I think we called this thing, what did we call this? ImageNet labels.txt. So image, there we go. That autocomplete, that looks pretty good. And then this one, we haven't downloaded that yet. So we also need to change this to the MobileNet model. So I need to swap that one out. So I have to change 3 things here. So we need to copy this model. We'll go here and swap this one out, which would be the one I downloaded from TF Hub. Okay, that looks good. And so the one thing we're missing, I don't know if it'll know how to detect this bird, because it looks like it knows how to detect like a tiger shark and all this. So I like tiger sharks. Let's get a tiger shark here. So I'm gonna move this over, and I'm gonna find a tiger shark. So I'm gonna go here, find a tiger shark, and then here we go. This looks pretty good. This looks pretty big as well. I don't know what that is, but that looks interesting. And I'm gonna download it to my desktop. And then I'm going to move it into this location, into the images directory. So I'll just open up another tab here and in fact say pwd. And I can say mv / desktop tiger shark to images, like that. There we go. And then from here, I can actually just swap out the thing that I'm going to do the prediction on, which is this. Perfect. There we go. Tiger shark. All right. So I'm going to go through and run this, and let's see if it works. So pretty cool. 99% prediction accuracy. So what's awesome about what we just went through is that what this means is that now that I've got this physical device, not only can I download things from the AutoML model that I trained myself, but I can get any model anybody created, and as long as I have the labels and I also have the TF-Lite image or TF-Lite file from TF Hub, I can do anything I want, right? So this is a pretty powerful workflow that we were able to work through here with again with TF Hub here. So I could go to any of these models as long as they're in this particular format. Let's go back here, TensorFlow. As long as I say, I think Coral, I think it'll work either way because this will accept TF-Lite, but just specifically because we know we have a Coral device, I just select Coral, and I can go through here and down. Look, it looks like there's only 2 right now, but it appears that this is probably going to be something that's going to be filling up quite a bit with people creating these models and hosting them, and it's a great way to really leverage the power of really open source, right? Is downloading these things. So that's basically Coral. So the next thing that we'll talk about is we'll get into using the AWS ecosystem a bit here. So what we can do next here is go to, let me actually just reshare my browser, which I think will be a little easier to work with because there's too much stuff going on here. So I'm going to go here and I'm going to share my browser only. Okay, so AWS has their system called DeepLens. So I'm going to go to the AWS console here, and I'm going to log in and use DeepLens. And we can just go to auth here, and I'm going to put in and what's neat about this is that we're able to really kind of tie into a lot of the power that comes with the AWS cloud by using DeepLens. And let me just go through here and get into DeepLens here a bit. So the way DeepLens works is that you have this deep learning enabled video camera, which again is this camera right here. Ooh, this camera. And you have to plug it in. So we'll go ahead and plug this thing in, and then I'll turn on the power. And if you purchase it, you can order one here. Then you can register it as a device. So that's first step, is go through and you register it. Now as of this today, we've got hardware version 1.1 and hardware 1. I actually have this one, which apparently has been less troublesome than the version 1.1. Has got a little bit more problems, but I'm assuming they're going to continue making these things, so there may be ones after this. But the first thing typically you would do would be to create a new project. And so we can maybe make this a little bit smaller here. And in order to create a new project, they give you these project templates. And the project templates it's similar in a way to the TF Lite ecosystem, is that you can do object detection, you can do artistic style transfer, you can do face detection, you can do, hot dog recognition, cat and dog, action, all kinds of devices, but they're specifically designed to work with this physical piece of hardware. Probably the more interesting one to play around with first would be this object detection template. Now you also, though, could create a new blank project if you have the raw ingredients. But first, let's just go through and do this one. So I'll say next. And you can see the overview of the architecture is that you have the camera. The camera will look at a video stream, and it'll actually split the stream into two pieces. You'll have the really like a monitor stream, which you actually can plug an HDMI cable into it, which actually, you know what, I probably should do that very soon, which is pretty cool. Where you can actually just look at it from an HDMI cable, or you can do this in the browser, which is what we'll do today. And then also you can call out to a Lambda inference function, and that Lambda inference function will go through and do the predictions and then annotate the stream, right? So that's really the gist of things. Is you have a raw stream, you have something that goes through, does predictions by pulling in a model and doing the predictions, and then it annotates that stream. So for this particular project, we'll just call this object detection. Maybe we'll just say, September object detection. What does this do? Like detects 20 objects. So let's go ahead and say create. And now that I've got this project, I would want to deploy it to a device. So first I would need to look at what is on that device now. And I think I can go here and take a look at it and say, remove this project. And I don't know, it does say it's offline, which I don't know if I have to reboot this thing or not. But if I go back here, let's see if we can see if it wakes up. Devices. Yeah, I might have to reboot this thing. Yeah, it should. Yeah, it should wake up. They're a little bit finicky. That's the one problem with this particular device. I think I can actually. This is one I could actually deregister because it's an older one. But this one, oh good, it's registered. Okay, there we go. It woke up. It looks like it's on. So what I can do here is I can say deploy a project and select the project that I just registered and say deploy to device. Select the target and then go through and do a review. So once I do a deployment here, it takes, let's say 20 seconds, maybe at most to do this. But this will now deploy the information that will hook it all up into this ecosystem that will allow me to not only just do some of the stuff that we've been doing earlier, which is do predictions on a piece of hardware, but it interacts with the cloud. So I think this is really interesting in that this Deep Lens device allows us to do a lot of things that would typically be very complicated to do without this cloud integration. And a couple things to point out as well is that there are two ways to really monitor, two main ways. There's a couple other ways as well, but to look at what's happening. One is that we can literally look at the video output and actually look at it detecting in real time in my office and seeing what's happening. But we also can look at the MQTT protocol messages and actually look at the IoT console and actually see what's happening. So I can see the payloads being sent in real time. And so we can see here it's still working. But if I go to copy this and I copy this, I can open up another window and go to the IoT console. And in this MQTT client, I can subscribe to a specific topic. So I'll go here and I'll say subscribe to this topic. And from here, what will happen is once it starts recognizing the things that are in my office, I will actually get the messages will actually pop up right here. So let's kind of wait for this thing. Okay, look, it looks like it's succeeding. So in theory, this thing should be, there we go. Look, notice how it's seeing things now, right? They're popping up. So what is it seeing? Well, this is pretty cool because I could write Python code, right, that talks to this and accepts it and does some other thing with it. But we also can look at it in real time. And if I go to this console here, I can actually look at the project output and view video output here, which will go to select my browser, Chrome, and then say view the stream. So again, there was two ways to connect this. I could put an HDMI cable, and I actually have a couple monitors in my room, so I could just put one somewhere and look at it. Or what's great, because I can show this, is I can just view the stream here, and then go to advanced and then proceed. And from here, I can go through and I would have to type in my password to accept this. And then what happens is it shows me the project stream. So this is, again, my office. Look, it sees the sofa, it sees a potted plant, it sees a person, and in real time it's detecting all of these labels. And then these labels are also getting sent into the IoT system, right? So pretty cool that it's able to maybe even take a little screenshot which is pretty neat here. And I can put that into our notebook. But in a nutshell, this is pretty awesome because not only do I get access to it there, but I also can get access to it from this, right? Maybe even take a little screenshot here. So what I typically do if I want to put these into a notebook, this is just a neat little trick, is I do an issue, and then I'll just say images, for example, more images, and then I'll take screenshots and I just throw them into like this here, and then here, and then I can just throw these. I can make these like a ticket, and then I can go back to my notebook and say, like, for example, I want to make some more stuff here, like AWS Deep Lens examples like this. I can do this and paste those in, and look, now they show up, which is pretty cool. And then I can just save it like this, and then check it into GitHub. So that's just a neat little trick if you want to share things with other people. All right, so now that I've got that working, the only other thing that maybe you can shell into it if you want, you can do all things with it, but the main thing to be aware of is that it has a function that's a Lambda function that you could later, if you wanted to, go into AWS Lambda and actually literally modify the code yourself. So you could go through here and change anything you wanted. Like, notice that it's got the same thing. It's got the labels associated here, and it's looking to see if it matches any of those labels. And then both sending the data to IoT, but also annotating the image itself so that you're able to see what it is. And then the other thing that it does that's in this project content is also the model itself. And the model lives, it literally tells you where it lives. The artifact path is stored in S3. So it literally sucks this out of S3. So if you wanted to train this yourself, you could train your own model. And in fact, with some of the tricks that we've done today, maybe you could even use a model from another library or framework, use Onyx converted, or use MXNet converted, or whatever, and then go through and tweak this particular function here and make it do the prediction. But so maybe the last thing that I'll do is I'm going to go back to the projects, and I'm going to create one more project, and I'll do a different one. This one will be artistic style transfer. And this is an interesting one because style transfer, what it does is it actually in real time, it changes the video image to be a different image. So this is basically like augmented reality format. And so if I select this, we can go next, and notice what it'll do is it'll grab the scene, and it will constantly be frame by frame, actually changing the frame and making it look like a Van Gogh painting in real time. So again, this is augmented reality. So if I go here and I name it something, so I'll just say September artistic style transfer. I can go here and then say we've got that working, and I want to deploy it to the device. So I would go back to my device and grab this particular project and remove it, and then deploy a project and pick this one, and then say deploy, and then put it onto this. Okay, so yeah, we want to replace it, sure. So this will take just a second, and then this will be a totally different style because it won't be something where I'm going to be looking at the labels. It's going to just frame by frame replace the output and put this new output inside of here. Okay, looks like it's working. Deployment in progress here. This will take just a second. Okay, it looks like it's working. So now how do we look at this? We can again look at the video output stream. So I can go to the browser, view it, go through here, put in some credentials. Okay, and now we'll get a real-time transfer, right? Style transfer, right? So pretty cool. I can walk back, put my hands up, right? You can see that it's a little bit laggy, right? But it does show the same thing. It does show that you're able to kind of frame by frame build out something. So yeah, I guess in a nutshell, the main takeaway here is that really there's a lot of ways to do computer vision, including fully integrated solutions to the physical hardware, like the Coral device, and probably one of the best workflows would be the AutoML to Coral or AutoML to a physical device.